Advanced Machine Learning Classifier. And also please note that we just released the software to second week of February, and up to now we reached nearly 100 plus downloads. Hope those who are downloaded, they are using the software. And also please note that this is the first version. We are trying to make more stable version. We are planning to give major updates by every month, so then only we can make a really robust version of the software. I will show like our second software, CNN parameter tuner, that is really robust version because that is a fifth update. I will show that later. So yeah, so we can just go through the software. Yeah, as I told that our aim is to bridge machine learning divide. So we developed the first software, user graphical user interface, and it's worked with Windows. It's a .exe application, so it just works with any Windows system. And note that if you are dealing with really good classification problems, it depends CPU, so you need really good CPU. I mean, for the normal task, you just need 8 GB or 16 GB, that is enough. So I will just show the key features of the software, then I will show like how it will work. Just a small demo. Yeah, the first feature is that you can load image formats such as JPG or PNG. I told that this two software, they're initially incorporating digital image processing. So that's why we are only dealing with the digital image. So here, once we load the image, it automatically resize to 150 into 150 pixel size. So that's we are going to change in our second update. We are going to make a user option for changing these kind of stuffs and also adding parameter tuning. That I will show how we did with our second software that we are going to exactly implement on this. And also the second key feature is that we integrated convolutional neural network. It's a part of deep learning, a kind of algorithm in deep learning for especially for image classification in the traditional machine learning, because this classifier, advanced machine learning classifier, deals with classical machine learning algorithm. You can see here like the algorithms like random forest, support vector machine, decision tree, and so on that are listed here. We normally call it classical machine learning algorithm or traditional machine learning algorithm. So in that algorithm, we need a feature extraction task. Normally, we were using gray level co-occurrence metrics, GLCM, and LBP, lower binary patterns, and so on for the feature extraction process. However, we used here CNN because CNN is really best, and we also did some research, and it's also currently under review. Also, one of our paper is also initially published based on that. We just came up with the solution. CNN is the best feature extractor. That's why we integrated here for the feature extraction task. And also with the SVM algorithm, I'm not sure that if you're familiar with the SVM, but if you are familiar, you can see that in the in our GUI, we also added option for custom SVM kernels. And also, moreover, that apart from adding CNN as a feature extractor, we also added bagging. Bagging means like we are splitting the data. I mean, that data set what we are giving for the training and testing. Again, we are doing with the help of bagging. It will create various training testing set, and it will find out best results, and it will make a voting classifier. So it will enhance algorithms. So that's why we added that here. Also, we added the option for flexible training testing set, because in machine learning, we need to define training and testing ratios. Here, the users can define training and testing ratio. Also, the other feature that we added here is error identification. So if you are familiar with the classification, especially for the image and so on, maybe you are familiar with the term confusion matrix. In the confusion matrix, I will also show what is confusion matrix in our demo. So in the confusion matrix, we can see how many images are classified as correct and how many misclassified. So what we added here, instead of just showing the confusion matrix, we are finding out which image misclassified, like from which class to which class. Like, just think that if we are an example of cat versus dog classification, the cat image 125.jpg classified as a dog, something like that. So in normal way, we will not get which image is misclassified. So here we are providing option which image is classified with the exact file name of the image. So you can go and check in the directory if the image is exactly relevant for your research, or did you, I mean, you already did some mistakes, like the labels are missed, or I mean, exchanged like in a incorrect way or something like that. So for that purpose, we added this option, especially for if we are dealing with really large amount of data. So you can't see this option anywhere. I believe that it's only in our, I mean, it's a simple task, but we can't see in any GUI. And new predictions. So I told that we added option for training testing, and also once you train with any machine learning models, what I mentioned here, like the algorithms like decision tree, random forest, or anything, once you train the model, you can upload a new set of data. You can just do a prediction entirely new. And also just like how we will get the result in, if we are using a Python or R for machine learning, like visualizing the confusion matrices and getting the classification, detailed classification report, like the accuracy, precision, recall, and so on. So these we already like added in our GUI. So if you are downloaded, you can just try with me, or you can just try later. It's not a problem. So here I'm just adding the link for my GUI. So now I will show the software, the first software, that is machine learning classifier, advanced machine learning classifier. Hope you can see here. So this is the classifier. So once you go through our Zenodo page that I was showing there, you will also get a handbook. The handbook also mentioned all the details, how to do the classification from the even from the installation to the end process, with the screenshot and everything. So if you are not getting with the presentation, you can just go through the handbook, and it's detailed. It's already mentioned there. So I will just show an example. So before that, I will just show you a data what I'm going to use here. So here I'm going to use as bar data. You can use it's a small data, nearly 480 for something images. You can use any data. What you need to do for the classification, just create a folder. So here I just created a folder and the subfolder, because this will be my classes. So I told that here I'm going dealing with the image classification of bark images. So here I mentioned the subfolder names, like the classes, because the system, our software automatically detect this folder name as class labels. So that's why I mentioned like the classes as the folder name as class names, like Betula pendula. You can see the picture here. So I just added a bark image of Betula pendula. So something like this. So you can use any, like in this example, because I'm working with the tree species classification, that's why I was showing the images with the bark. You can use any data for the classification. You just need to create the folder like this. So even like the cat versus dog, you can also do this as a binary classification. So I just created a label cat, and the folder name also cat, and here I'm also doing. So you can do whatever you want, just to make the folder structure like this. That's all. Yeah. So I will just open the data. I mean, yeah. Okay, so I will just go with the bark data. So, please note that this is just a demo. So if you want to get really good accurate results, then you need to go for really good data set and also other tuning options. But we don't have that much time to show that. Yeah, you can see here. Also, we also added a command prompt area like here. So you can also see the values that you are dealing or selected. So here you can see the directory, the image path you selected, and here you can use the algorithms. You just need to click what algorithm you want to use for this classification specific. So I'm just going with the random forest, and here the training testing set I mentioned. So it's important to note that if normally we are using 80 20% for training and testing, 80% for training, and 20% for testing. So in our case, if we want to use a 80% data, you need to mention like 0.8, because I already mentioned that we are taking the value like this. It means like 80% of data for training. If you want to use a 60% of data, it will 0.6, it will take 60% of data. So I'm just going with 80% of data for training and 20% for the testing process. Yeah, and also if you want to make this command prompt area a bit bigger, and there is an option called magnifier, like how much percentage you want to make it like bigger, something like that. So you can see like this. Yeah. Yeah, so we just, because this is the initial update, the initial version of this advanced machine learning classifier. That's why we didn't add a lot of stuff. In the later updates, we are planning to add parameter tuning for each algorithms here, with users can define parameter values by themselves. So we are planning to do with our next update, those kind of stuff. So now we added the data and the algorithm we selected and training testing split. And now we just need to go and do the classification. Just go to the run menu and click on classify images. And you can see here in the command prompt area, the images will be loaded. So exactly like how it will load in a Jupyter interface or any Python interface. If you're dealing with, like, instead of this GUI, if you are just directly going with a Python script or something, you can see like the data will load something like this. And here you can see that the original data shape, that is nearly 6,960, like I mean like the width and height of the image. And you can also see that 3, that is the channel, because if here we are using color image, that's why it's showing 3. If you are using a black and white image, that will be just 1. So yeah, so it will take bit. I believe that it will only take nearly 1.5 minutes, because it's just 484 images. And also, if you are, I mean, if you want to use really good data, like more than 2,000 or 5,000 or 10,000, anything, like, you can use the same software, but the thing is that it will consume more RAM. So you must install it on a good system, then only it will work efficiently. Also, we are integrated all the environments, Python environments, because we build this software with the help of Python. So we integrated all the Python libraries, environments, and everything inside our software. So that's why our research software consists nearly 700 MB in size. And also, if we are working, I mean, using the software, it will also uh, take bit more CPU. So that's why I will say, like, if you're working, don't move the software. It will show like not responding. Anyway, it will work, but it will just show the option like it's not responding, but you need to wait and it will finish the process. And also, you don't need to install any other libraries or anything. You just need to install the software. That's all. Just like if you are programming with Python or R, you need to install different library for loading the image and so on. But in this case, we don't need to just install the software. That's all. Yeah. So once we finish the processing, you will get a classification result, something like that. It will mention that 81% of accuracy and precision score, recall, F1 score. Yeah, just okay. Yeah, and you can see here, even this is a small classification. I will not say that it's a big, really good classification, because you can see that the Betula pendula is misclassified a lot. And but other classes, it's really good. And however, in our case, I just add a small data set because we don't have enough time. And also we need to show our new feature, misclassification report. For that, I need definitely misclassifications. Yeah, so you will get the confusion metric, something like this. And you can see here that I was telling the confusion metrics. So the first class is Betula pendula. This is the original label, and it's this we need to check with the prediction label in the down here. So that means like the 14 images from Betula pendula is misclassified as Betula pendula, and 1 is misclassified as Carpinus, and 9 is misclassified as Larynx, and so on. So this is the misclassification. Normally, we will only get the detail, like the numbers, how many image misclassified, and we don't know which image. But in our software, we can. We know. I mean, I will show that how we can identify each misclassified image. This. Yeah, so I will just show this result in the command prompt area. Also, you can also see the results, like how it's processed and how much time it took, and so on. And here you can also see the accuracy, decision, sorry, precision, and so on, and also the class wise accuracy. And here I mentioned, and here the first class Betula Pendula is 0, and the second is Carpinus like 0, 1, 2, 3. And here, and if you save the misclassification report, it will also match this indexing, like 0 means which class, 1 means which class. Anyway, we can identify it, like the first one is 0, that is Betula Pendula. So you can also get the class wise accuracies and so on, and you can also see the exact same reports here. So if you want to save this result, you can just go with the file option, and you can see here save confusion matrix. So it will just save the confusion matrix. So I will just show. So AML outputs. Yeah, so I just select the folder, and this confusion matrix will be saved there. I will just show that. Yeah, you can see here. The confusion matrix is saved there. And also, if you want to save your classification report, just save the classification report, like how we will get in a Python or other programming language. Sorry. Will also save as a text file, so you can see the classification report, training, testing, algorithm selected, and so on, a detailed report. I mean, if you want to do some future works and so on, otherwise it's not necessary. Yeah, so we saved the results. So I told that misclassification report. So we can see here in the first class, and also in the third class and fourth class, there is misclassification, but it's higher in the first class, Betula Pendula. So yeah, here it will just show the one, or like sometimes it will show 10 image, because it's more than 10 image. So we will get all the details in the classification report. For that, it's mandatory that we need to save the misclassification report. So I'm just saving there. I will show our misclassification report. Yeah, we save this. So, yeah, it's an CSV file. So this is the index. That's not necessary for you guys. So yeah. So this is our misclassification report. This is the labels. I told that it was showing in the command prompt area 0, 1, 2, and this is the exact indexing for that. And this is the first misclassified image, the true label. Originally, that image was Betula Pendula and is misclassified to Larynx. And the image, this is the image file name. So you can identify all the misclassified image and their true label and misclassified to what label, and also their corresponding image file name. So if you accidentally added Betula Pendula with Larynx or something, some misclassified, I mean, what we did in the while we making the folders, so we can identify. That's why we added this a new feature to identify all the misclassified image with their corresponding file names. Yeah, so that's all. So that is with our machine learning, advanced machine learning classifier, because I told that this is our first version, so we are planning to integrate more uh, features like the parameter tuning and so on. Sorry, I forgot, like the image prediction. So I told that we can also do the prediction. So for making prediction, what I did, just a second. Yeah, for the prediction, I created a folder, and here I added images. The first one is BP Betula Pendula, and just 3 images, 4 images from Betula Pendula, and Carpinus Betulus, 2 images from Carpinus Betulus. In the prediction process, you can just mix everything. because I just want to show that which one is misclassified. I mean, based on the accuracy, like how much got for the training, then only it will work the prediction because it works based on the already trained model. So I'm just going to use this data for the prediction process. So I will just show that. Just I'm going to upload the data. So yeah, here is the prediction. So I'm just uploading that entire folder. So you can see in the comment prompt area, it's loading each one by one image. And you can see here that our prediction. In the prediction, we also added the probabilities. So you can see like I already renamed the picture name BP Betula Pendula. Yeah, it's classified as Betula Pendula and the confidence was nearly 40%. And the probabilities, the higher chance it was confusing with the other labels. You can see here. And also the second one also Betula Pendula, third one also Betula Pendula. But I will just show that results more detail. I will save that as prediction saved. Yeah. Yeah. So yeah, here also, yeah, because this model achieved nearly 81% accuracy. That's why you can see the misclassification here. Because especially we saw that here in our Betula Pendula, it was misclassifying lot. So that's why we didn't go. Everything is in the prediction, everything was Betula Pendula. So if you train the model with more, I mean, good data set, we will not face this problem. So that's all. And what if you want to repeat, now you can see that we didn't got really good accuracy, so we need to repeat this process. So once, if you want to repeat the process, you just need to clear the kernel and the data. So here is the option for clear. So just clear and it will just work from the beginning. You can just load the new data or the same data. You can deal with the different algorithm, training, testing size, and so on, and it will just do as a new task. And here we also added just basic information about the algorithms, what we added here. You can also see because this is the initial version, that's why we only added basic stuff. In the upcoming versions, we are also adding to make it really robust ones. And also it's about the application, and you can see the details like what we are incorporated here. And also if you want to get more detailed like scripts and so on for each algorithm separately, you can just go visit our GitHub repository. Yeah. So